Sound as a mechanical wave. Mechanical waves are defined as waves that need a medium or substance to move through. We covered that in the last chapter. We're just reminding you. If there is no medium, like in a vacuum or in outer space, a mechanical wave won't propagate, fancy word for move, from one point to another. Without a medium, sound waves will not propagate, right? In space, no one can hear you talk. So they are classified as a mechanical wave. What medium do sound waves move through in your classroom? What other media do you think they can move through? Answers on the next slide. Sound waves move through the air in your classroom. That's the medium. They also move through walls. Many times you can hear somebody in the next classroom talking. They also move through water. That would be sonar. But they don't move through space. There's no air there, so there's no medium for them to move through. So here's an interestingly titled video, Sound Waves in a Vacuum. Please click and watch it. Let's see if we can visualize these sound waves. We have a pipe. That's the two horizontal lines there. And then look at the left. You see a gray bar moving back and forth. That's going to switch from pushing air molecules to the right, and the air molecules are the black dots, then pulling them back to the left. And you're going to say, wait, what are those red dots doing there? Well, that's for the next slide. Okay, now pick any one of the dots. And we colored a few red so you could make them easier to follow. But if you'd like to watch a black dot, that's great also. Now, what does it look like, this whole picture? It looks like something's moving to the right, right? These vertical bars here of particles, they're moving over to the right. Well, let's see what's really happening to the actual particles. So let me first erase those aids there. All right, let's say you pick this red dot. You see it moving to the right, and then what happens? It moves back to the left, then to the right. It really isn't going anywhere. It's oscillating around a fixed point in space. So none of them are making a full trip from the left to the right. So what we have here is this bar moving back and forth is analogous to what's happening when you talk. At some point you push sound out. Frankly, when you say the word push, you can feel the sound leaving. And then when you take a breath, you're sucking some of the air back in, some of the particles in. Then you push it again. That wave disturbance propagates through the air. So at the other end, they can actually hear what you said. But it's pretty nice that the particles aren't going from your mouth all the way over to somebody else's head. First of all, they can't move that fast. Sound moves faster than what a little particle can move. And that would be kind of disgusting. So just summarizing, the air particles, that's what we have here. We'll call the medium air, and you're talking. The air particles just oscillate around a fixed point, but the wave moves all the way over to where somebody else can hear you. Last chapter, we talked about transverse waves. That's where the particles vibrate at a right angle to the direction that the wave moves. So we described water waves as transverse, right? The wave from the ocean comes in and hits the shore, and you can see it going up and down. But if you have a person here or a big piece of cork or styrofoam, you'll see that they just keep going up and down and not moving any closer to the shore. Now, to truly understand wave motion at the beach, it also does have longitudinal waves, but we're not going to worry about that now. So longitudinal waves, which is what we're defining here, those are waves where the particles vibrate in the same direction that the wave moves. Sound waves are longitudinal waves.